comes to mind is the type of diagnostic connector used in a vehicle, or the standard that that vehicle was designed to meet. But is there more to OBD? Hi, I'm Clint. There are several key elements that form part of OBD, or its equivalent EOBD, which are detailed in the SAE and ISO standards. These key elements were implemented in various countries in line with their local laws and regulations. Countries like the United States achieved full implementation of all the OBD standards, including the revised version of OBD2 in 2005. These OBD2 standards can be broken down into several key elements, including the protection of key emission components, engine control unit security, scan tool interface and communication requirements, and OBD diagnostic connector specifications. Let's take a closer look at these particular key elements. With any modern vehicle, the first key component to protect in the engine management system as part of OBD2 is the catalytic converter. The converter is responsible for the conversion and reduction of harmful pollutant gases before release into the atmosphere. The catalytic converter is closely monitored by the engine management system in all modes of engine operation as part of the OBD2 standards and their equivalents. Monitoring is achieved on a gasoline engine by careful control and adaptation of numerous engine parameters and operating conditions. Fine mixture control is the most critical aspect for efficient conversion. Anything that has an adverse effect on mixture control has the potential to cause permanent damage to the catalytic converter, which in turn will cause the vehicle emissions to increase into an unacceptable range. This mixture adaptation can be viewed on a scan tool as short and long-term fuel trims. These are critical values when used for diagnosis. Heat is another important contributor to catalytic converter operation, which is carefully modelled by manufacturers to ensure that it remains in an efficient and safe zone under all engine operating conditions. Part of this heat control is evident from a cold start, where an ECM strategy is used to rapidly heat up the catalytic converter in a controlled manner. Typically, temperatures above 300 degrees Celsius are required on most vehicles for the catalytic converter to begin to operate. With the latest emission standards, such as revised OBD2 or Euro 6, this target temperature needs to occur within 30 seconds from engine start. The ECM is constantly fine-tuning mixture and ignition timing control, as well as other areas such as valve timing, exhaust gas recirculation and engine temperature, all to ensure that the catalytic converter is operating at its most efficient temperature. In some instances, due to vehicle operating conditions or faults, the ECM may run a catalyst protection mode. Through sensor feedback, the ECM estimates conditions that could cause the catalytic converter to reach excessive temperatures. If overheating is determined, the engine management system will use various operational strategies to control this temperature, which will have a cooling effect on the converter. For more information on catalytic converter operation, please refer to our other training modules on this subject. While exhaust temperatures are considerably lower on diesels than the equivalent gasoline engine, strategies are still required by the engine management system to regulate catalyst temperature for an efficient control of emissions. These engines may also be fitted with additional exhaust after-treatment components, which require sufficient heat levels to operate and transition to regeneration modes. The ECM will control engine fueling using the injection rate, quantity, and timing to achieve a target exhaust gas temperature for a specific mode of operation. This in turn will change the operating temperature of the catalytic converter, which may be used as part of the exhaust after-treatment process. The humble oxygen sensor is a critical device used for mixture control feedback and is used extensively as part of several main monitors under the OBD2 standards. The oxygen sensor itself must be heated rapidly so it can provide instant feedback from initial start. Temperature control is managed by the ECM using pulse width modulation. In most new vehicle applications, a post-catalyst sensor is fitted and is used to determine efficiency of the converter, as well as verification of the pre-oxygen sensor signal. When a vehicle is manufactured to meet specific OBD standards, part of the requirement is to ensure that it continues to operate and meet those standards for the usable life of the vehicle. One measure put into place that ensures that this occurs is inbuilt hardware and software security. The days of removable EEPROMs have gone. All ECMs are now a self-contained unit that can only be reprogrammed using OEM software via a dedicated portal. There are also specific checks in the ECM software which are designed by the manufacturer to identify if any changes have taken place that are outside of the factory specifications. This helps to ensure that critical emissions-related information is not tampered with by those seeking to change a factory program that has been developed to meet OBD2 standards.